Hi all, and thanks for joining. Today I'm going to walk you through this very easy Linux box called Funnel, available on HTB platform. This is the 8th box from the so-called Starting Point series of machines and Tier 1. You need to walk before you can run. The tags for this machine are FTP, PostgreSQL, Reconnaissance, tunneling, password spraying, port forwarding, anonymous guest access, and clear text credentials. I already downloaded the official write-up. I'll proceed to connect to HackTheBox Starting Point VPN network by using OpenVPN and start the target instance. While I'm waiting for target IP address to show up here, I'll proceed to go through the official write-up, though I'll focus mostly on hands-on part. In introduction, it is mentioned that the overarching topic of this box will be tunneling. So let's go through these 3 sections. The first type of tunneling we are going to take a look is called local port forwarding. When local port forwarding is used, a separate tunnel is created inside the existing valid SSH session that forwards network traffic from a local port on client's machine over to the remote server's port. Under the hood, SSH allocates a socket listener on the client on the given port. When a connection is made to this port, the connection is forwarded over the existing SSH session over to the remote server's port. The second type of tunneling is called remote port forwarding, also known as reverse tunneling, and as one can imagine, it is exactly the opposite operation of local port forwarding tunnel. Again, after a successful SSH connection, a separate tunnel is created, which SSH uses to redirect incoming traffic to the server's port back to the client. Internally, SSH allocates a socket listener on the server on the given port. When a connection is made to this port, the connection is forwarded over the existing SSH session over to the local client's port. And the third type of tunneling is called dynamic port forwarding. The main issue with both local and remote forwarding is that a local and remote port have to be defined prior to the creation of the tunnel. To address this issue, one can use dynamic tunneling. Dynamic tunneling allows the user to specify just one port that will forward the incoming traffic from the client to the server dynamically. The usage of dynamic tunneling relies upon the SOX5 protocol, and it provides a means for UDP packets to be forwarded. And to go deeper into tunneling, you could, for example, check out this pivoting tunneling and port forwarding module on HackTheBox Academy, then tunneling protocol on Wikipedia and secure shell tunneling. Also this detailed guide on legal.ng on hacking articles. Let's pause now with walkthrough and proceed to ping target instance IP address to verify connectivity. Great, it's responsive to ICMP and TTL is 63 as expected for Linux machine. Let's proceed to run nmap command from the instruction, which switches SCSV, and we expect to see port 21 open and 22. Let's save this nmap output into our notes. 21, we see anonymous FTP login allowed, and we immediately see one directory. And port 22. Though according to the walkthrough, let's proceed first focusing on FTP and anonymous access allowed. So let's first run FTP-H to see available switches and options and proceed to connect to FTP service of the target instance. And for anonymous access, we'll use name anonymous. Then for password, just enter. And we're logged in. Now let's type help. We expect to see dir available among listed commands. Then there is listed this mail backup directory as seen in the nmap output. So I'll proceed to switch to it and download files available over there to my local attacker machine, and then proceed to open those files to see what's in there. So let's now run get password policy PDF, and then let's get welcome and exit from here. To verify I downloaded the files, here they are, and let's use open then space dot to open the graphical interface of the directory where they are stored. And from here I'll proceed to open PDF. Okay, let's first open PDF. And that's the one. From here we should read through this password policy in detail and take note of the default password mentioned that could be used for internal systems access. Let's note it in the notes file. And let's see what we have available in the welcome. Let's save them in the user.txt file. And let's save just the first part of the email addresses, so before @funnel.htb. I'll rename my users.txt file to usernames.txt file to follow along the walkthrough as much as possible. And let's now try to brute force our way into the SSH service with these usernames and the default password and using Hydra tool. So let's check if I already have Hydra on my system. If not, use this command to install it and proceed to run this command a bit adjusted to see if any of these listed users can log in via SSH to the target instance by using this default password we found in the password policy PDF. Let's put here the target IP address. And SSH port is default 22, so we don't have to add anything else. And let's try this. Let's check if the target instance is still up and running. Let's try again with the above command. Let's verify my list of usernames, because according to the walkthrough, this password should match for Christine. I have Christine mentioned in the usernames txt. Let's verify my spaces in the txt files. Maybe that helps. Or let's try removing space. It might be that I have additional spaces. Let's try again. And now there's a match for Christine. And let's proceed to use these credentials to gain remote access to the machine as the user Christine. Great, we are now switched to Christine's terminal, Christine at funnel. And let's now proceed to run socket statistics with switches TLN, T to display TCP sockets, L to display only listening sockets, and N, do not try to resolve service names first. So let's see what Christine can see. Great, our output looks similar to the screenshot, and according to the walkthrough, we'll proceed to focus on service running on port 5432. And let's read just this portion of the section. The crucial column from this SS output is the fourth column, which displays the local address on which a service listens, as well as its port. 127.0.0.1 is synonymous with localhost, and essentially means that the specified port is only listening locally on the machine and cannot be accessed externally. This also explains why we did not discover such ports, for example this 5432, in our initial Nmap scan. On the other hand, the addresses 0000, star and 2 columns, that would be this row and these last 2 rows with port 22, 21 and 22. Those indicate that a port is listening on all interfaces, meaning that it is accessible externally as well as locally, which is why we were able to detect both the FTP service on port 21 as well as the SSH service on port 22. And let's now run ss command without switch-n to see the name of the service for port 5432. And that will be PostgreSQL. With PostgreSQL, we can interact using PSQL command line tool, and we'll proceed to check if it's already available on target instance for Christine user. It's not. And that's according to the instruction, so we'll proceed with the tunneling approach. Here we saw with Christine user we do not have administrative privileges, and the service which most likely has the flag is hidden locally on the target machine, and the tool to access that service, PSQL, is not installed. While there are some potential workarounds involving uploading static binaries onto the target machine, the approach for this box will be port forwarding or tunneling using SSH. As stated, there are multiple options to take at this point when it comes to the actual port forwarding, but we will opt for local port forwarding, and you can find the dynamic version in this document appendix. We'll try with dynamic version towards the end of the video, but for now let's proceed to run this command, adjusted for our target instance. In the scenario we are currently facing, we want to forward traffic from any given local port, for instance 1234, to the port on which PostgreSQL is listening, namely 5432 on the remote server. We therefore specify port 1234 to the left of the localhost and 5432 to the right, indicating the target port. So let's proceed to run this command. So PostgreSQL is available looking from Christine's user at target IP address from its localhost 5432 port, and we'll map that to our attacker machine, local port 1234. So let's try with that. And I'll proceed according to this side note. We may elect to just establish a tunnel to the target without actually opening a full-on shell on the target system. To do so, we can use the -f and -n flags. Keep in mind these are case sensitive, which A, send the command to the shell's background right before executing it remotely, and B, tells SSH not to execute any commands remotely. And then I'll proceed to run ss-tlpn to see if I have port 1237 on localhost in listening state. Let's try with that. Let's run this command from our local attacker machine. So keep in mind to differentiate it from Christine user at funnel. So that should be your local user at your local attacker machine. And let's add switches big N, small f, looks good at the moment. Password is the default one. Let's verify with SS. We expect to see 127.0.0.1 and port 1234 in listening state. Great, looks good at the moment as expected. So in order to interact with the remote servers, we must have PSQL available locally on our system. So we saw Christine did not have it available. My system is already up to date. I'll verify if I have PSQL already available on my system and proceed to run psql-u christine-h localhost-p1234 command. Using the PSQL and established local port forwarding, we can now interact with PostgreSQL service running locally. We will make sure to specify localhost using the -h option, as we are targeting the tunnel we created earlier with SSH, as well as port 1234 with -p option, which is the port the tunnel is listening on. And here let's use again the default password for user Christine. Great, that worked. And in order to list existing databases, we can execute \l command, short for \list. And here is the page for PSQL command line tool. Okay. Great. As seen in the walkthrough, we have secrets listed, so we'll proceed to connect to secrets database. Let's now dump its tables with \dt. And there is one table with the name flag. Let's select all from flag. And there are flag characters we need to copy paste to answer the last test question. Great, so with this we completed the official part of the room, though we can go through this additional section to try to get to the flag by using dynamic port forwarding, and I'll proceed to do just that. Let's exit from here also. Let's now proceed to run this command and adjust it for our specific target IP address. Don't forget to kill the process associated with local port forwarding. Now we are using dynamic port forwarding. Let's try again, but this time faster. Great. And now from our local attacker machine, let's run this PSQL command as we ran it previously. Though by running it this way, it's expected for it to fail. We have to add this one line to etc proxy chains for .conf file. So the line should look like this: SOX5 127.0.0.1 and port 1234. And then prefix this PSQL command with proxy chains. So let's try like that, and let's see if that will lead us to Christine's terminal. So let's locate where is proxy chains conf file on our local attacker machine. And over there, let's ensure that strict chain is not commented out. Dynamic chain and random chain should be commented out. And for SOX5, let's specify 127.0.0.1 match with port 1234. Strict chain is not commented out. Dynamic chain is commented out. And random chain is commented out. And at the bottom, let's find SOX5 with Control W. SOX5. And let's add it here. Let's comment out this one. And adjust this row for SOX5 and port 1234. And let's redo this, but using sudo permissions. And let's run this command now, prefixed with proxy chains. That should drop us to Christine's terminal. Let's type Christine's default password once again. Great. And from there, as previously, we would proceed with \l. See the secrets database. Then connect to secrets database with \c secrets. Then dump its tables and select all from table named flag. Great, that works as expected. So with that, we completed the hands-on part. And let's switch now to HackTheBox user interface to answer tasks questions. Task number 1, how many TCP ports are open? So we saw in the nmap output, port 21 and 22 is open. Task 2, what is the name of the directory that is available on the FTP server? That was the directory we switched to, this one. What is the default account password that every new member on the funnel team should change as soon as possible? So that was the password we used for Christine and as seen in the password policy doc. Task 4, which user has not changed their default password yet? So that's the mentioned user and user used with Hydro tool. Task 5, which service is running on TCP port 5432 and listens only on localhost? We used tool PSQL for that service. And let's verify in our TCP and UDP port cheat sheet. Task 6, since you can't access the previously mentioned service from the local machine, you will have to create a tunnel and connect to it from your machine. What is the correct type of tunneling to use? Remote port forwarding or local port forwarding? And that's port forwarding with switch L we used. Task 7, what is the name of the database that holds the flag? So we saw secrets. Task 8, could you use a dynamic tunnel instead of local port forwarding? Yes or no? So we tried that and it worked. And after submitting characters from the flag database table, we can say we open the box. That would be all for this video. Like and subscribe if you enjoyed this one. Until next video, bye for now.